Welcome to the databases course final project. Our project is named EV Charging Station Locator System in Nebraska. This project is done by Changwoo, Chiradeep, and Idriss. Motivated by the high demand for efficient charging solutions, as EV users face a lot of challenges when they want to locate the nearest charging station, for example, or if they want to reduce the time or the cost. And we had this from a personal experience that we once had when we were traveling between the cities of the Midwest. So we set a goal to build up a system that provides enhanced accessibility features with the management of centralized database that can even provide like more features beyond what we initially expect. Most of our data, we got them from the US Department of Energy. So this is our main source of all the data that we provided in the script with our entities, except for the user, which we manually created. So we have six main entities connected through between each other through some relations. As you can see, each entity has their own attributes along with them. Um, we have a user entity which connects to a charging station, and we suppose that there are direct routes between the charging stations for the ease of our project. And for each route, we want to compute the distance, and we have each visit to the charging station is recorded in a session. So for the database schema, this is these are the tables that we have for our six entities. We have one additional table that connects the user to the travel. Um, and we provided that table in the MLPQ text file provided along with the project. For the functions and queries, we have three main focuses. We either want to reduce the distance that takes each user to get to their destination, the time, the commute time between those stations or the different destinations, or the cost that each user need to needs to spend. So in the first query, if you look here, we provided an aggregation query to view the shortest distance that take each user we have in our system to their destination. So far we have five users in our record, and they have different destinations and different origins, as you can see. For user one, they want to get to from origin 9 to destination 11, and the shortest distance that takes them to where they want to go is 181 miles. For user two, they want to get to 11 as well, and they have almost 170 miles. And if you go all the way down, you can see different users and different destinations. For each respective destination, we calculated the shortest distance. In the second query, it has to do with time. So again, we have five users in our system, and they have different destinations. And this is the shortest time that takes each one of them to arrive to wherever they want to go. So for the first user, like almost 4 hours and a half. The second one is like almost 2 hours and a half. And all the way down as you go, you can see different time for the users. The third query I mean, is related to the cost. So for the five users we have, we want to see what's the minimum cost that, you know, each one of them needs to charge their EV car. So for the five users, we have different costs based on, I mean, depending on their location, uh, and where they want to go. As I mentioned before, we have records for each visit that a user stops by a charging station. So here the query has to do with those records. For example, we have user ID. We have a user, I mean a station whose ID is 5. You want to see at that specific station, what are all the stations we have in that specific station. So for that station whose ID is 5, it is located in Lincoln. It has two stations so far, and by default, the ID is 5. For the implementation of our data and MLPQ system, as we get our data from the US Department of Station, we dealt with a very big number of data, and those information were provided in CSV files. So as we mainly work on MLPQ system, we had to transform all of those data to a valid MLPQ format to be able to upload that to the MLPQ system. So we provided Python script that takes those data, parses them, and transfers them to a valid MLPQ format that we can use. And yeah, these are our 6 entities. They were organized in tables with the respective information. So we took that file, we gave it to our script, and we got the MLPQ format as you can see here. This is only one example. And one last thing to mention is for the user information, we randomly created those information, I mean, provided those information. Um, they don't have to do, I mean, they didn't have to do with with any of the sources that we got the data from. This is only an example that we provided along with our Python script. We have the map of Nebraska, and we have different stations as you can see here. And the to make it easy for the implementation part, we uh, suppose that all the stations are connected through direct routes. So these are not real routes between the different stations, but we just um, did that to make it easy for our project and to proceed further. For the moving object, we simulated that on MLPQ system. So you can see different EV cars moving in the space. So we provided a charging station systems that provides solutions for the time, the location, and the distance, which works very well actually. For the future work, we want to expand this database to include even more complex details and attributes, and we want to integrate machine learning for better prediction and usage trends. We want to incorporate real life data for any new charging stations that can be added later. And we want to support broader zone, either including the entire Midwest or even other states in the US. Thank you so much. And any questions you have?